In this video, we'll do question number 13, that is from exercise 7.1. The question says that we have to show 9 raised to the power n plus 1 minus 8n minus 9 is divisible by 64 using binomial theorem where n is any positive integer. As we know that for a number to be divisible by 64, it should be written as 64 into k, where k is any positive integer. For solving this, we'll be using this expansion formula for this binomial. We're going to apply this formula. Let's see how we can do it. First, I'm copying the question. This is 9 raised to the power n plus 1 minus 8n minus 9. What we can do first is that we can split this part, that is 9 raised to the power n plus 1 using laws of exponent. I can write 9 into 9 raised to the power n minus, and rest we will copy as it is. It is that is minus 8n minus 9. Now, in the next step, I'm going to write 9 using this relation. I can write this as 1 plus 8 raised to the power n, and then minus, this is 8n minus 9. Now I'm going to apply this formula of expansion. Let 9 be as it is, dot. This is NC0 plus NC1 into 8 raised to the power 1 plus NC2 8 raised to the power 2 plus NC3 8 raised to the power 3, and so on till NC n 8 raised to the power n. Now further these two numbers should be written as 8n minus 9 copied. I did the expansion of this part only, expansion of this part. Now this is 9 only. This is NC0 is 1 plus NC1 is 8, right? Therefore, this is 8n. Further, I can write the other parts as 8 square into NC2. I can write this as 8 cube into NC3. And at the end, 8 raised to the power n NC n. That is enclosed in a bracket, and then minus 8n minus 9. In the next part, we'll open this bracket, see what happens. If you open this bracket, you can see that 9 will be multiplied with each. So this is 9 into 8, that is 72n, plus this is 9 into 8 square, this is 8 square. 8 square NC2, this is 9 into 8 raised to the power 3 NC3, and 9 into 8 raised to the power n NCn. We have opened the bracket this time, minus 8n minus 9. We can see here that this positive 9 and negative 9 get cancelled, and we'll be solving this part, that is 72n minus 8n will give you 64n. Will give you 64n. So this is 64n plus 9 dot 8 square NC2 plus 9 dot 8 raised to the power 3 NC3, so on, and this is 9 dot 8 raised to the power n NCn. Now what we can do is we can take 64 as common. It's very clear from here that we can take 64 as common. If we take 64 as common, so I'm taking 64 as common. If I take 64 as common, what do we get here? We'll get this as n plus 9 dot 64, right? So this 8 square is 64 only. So we'll get NC2, and 64 is 8 square only. So where each power will reduce by 2. So it's 8 cube will turn out to be 8 raised to the power 1 NC3, so on. This is 9 dot 8 raised to the power n minus 2 NCn. right? So therefore, I can write this. I can write this as 64. I can write this as 64k, where k is any positive integer. Therefore, this is proof that the expression 9 raised to the power n minus 8n is divisible by 64, as it is 64 into some positive integer.